Okay, let's take a look at the studio for chapter 4 on data and variables. This is a pretty straightforward studio. You will be just declaring and initializing a few variables and then generating a report that looks exactly like this. They give you the end result so that you know what to shoot for, but it will involve a little bit of formatting and paying close attention to some of the details, like, where there's some spaces between things, where they might have labels on the end of some of the numbers. So we'll, kind of deal with each of those as we come across them. But there's a link right up here to get the starter code. I have already done that, and I've got the REPL here. I've added a few additional comments just to kind of help move us along. And at the very end, there's a bonus mission to add readline sync to your code so that you can ask the user to give you a value for the astronaut count instead of just hard coding this value 7 for that variable. So we'll do that. And then I also have some additional bonus missions that I have added because there is no coding studio for chapter 5. And I wanted to add a little bit on conditionals. So we'll kind of modify or refactor our code after we've written it for this assignment to add in a couple of conditionals and give you a little bit of a taste of what that looks like. A little bit of extra practice. Okay, so let's start at the top. First thing we're supposed to do here is to declare and initialize the 12 variables that are listed here for us in this table. We want to use the let keyword every time we declare a variable. So let date declares it, and then we'll initialize it to give it a value. And this one is going to be a string, 2019-03-18, and I'll end it with a semicolon. The next one is also going to be a string. This one will say 10:05:34 a.m. And then we've got a number. Let astronaut count have the value of 7. Astronaut status will be, if I can spell it correctly. My fingers are having a hard time, guys. Okay. Status is Freddie. And that's a string. Average astronaut mass kilogram. Okay, that's a long name, but it's descriptive and it needs to be because it's telling us exactly what their number represents. And this does need to be a number. We're going to be computing some things starting now. We'll calculate the value of the crew mass kilogram based on the number of astronauts times the average astronaut mass kilograms. So all we have to do is do exactly like they show it in the book here, and just multiply these two variables together, and whatever values they have will calculate. And then that value, the product of these two, will be stored in this variable. All right, fuel mass kilograms is just going to be hard-coded to 760,000. Remember that you don't put commas in when you have numbers in JavaScript. And then shuttle mass kilogram is going to be 74,842.31. Let total mass kilograms, and this is again where we're going to calculate by adding together the crew's mass, the fuel's mass, and the shuttle mass. And then the sum of those three gets stored in this variable. And that'll make it easy when we're printing our report because the math is already done and we just need to get the values of these. Okay, we have 3 more here. Let fuel temp Celsius equal. All right, this is a number. I'm going to go ahead and store it as a number, and we'll worry about labeling it as Celsius when we get to the report. Let fuel level be 100. Same thing. I'll add the % sign later. Otherwise, those would be a string, but I'd rather use them as a number. That's pretty common. If something can be a number, it's better to store it as a number in case you need to calculate something with it. Okay, this is just hard coded as clear, the weather status as a string. Okay, so now we have all 12. Great. We can move on and start working on this report. So if you remember from chapter 3, actually, console log is how you print to the console. We're going to be doing a whole lot of that. And we'll start out by, taking a look at this. This first section right here just has 5 lines. It's got a line of hyphens, a header, another line of hyphens that's identical to the first one. And then these 2 lines for the date and the time. And of course, we won't hard code these values Monday and 10:05. We're going to use the variables that we created that are storing those values instead. So I'm going to do this first part with 5 separate console logs, one for each line. That's a perfectly valid approach. But we'll look in a minute about a way that we can simplify things. All right. In order to get this line, generally speaking, I'm going to tell you it's better not to cut and paste or copy and paste, because you need to start building the muscle memory of coding. It's a very kind of different flow, the way that you type and move around while you're coding. And the only way to get past the learning curve on that is to practice. So, but this is like a very specific number of hyphens, so I'm going to copy and paste it. And I'm going to make 2 of those because I need 2 of them. But in between them, I will have a console log, and this I will type out. So it looks like we have this arrow and the space. LC04 is the name of the report. Then there's a hyphen and another space, and then launch checklist. That's all I need for that. And then after the second line, we will do another console log, and I will say date. And this is where I need to put a space after that colon. And then I'm going to use a plus sign to concatenate with the variable name, which is date. So that will take this string, and right after the space, we should expect to see the value Monday, 2019, March 18th, because it's stored in that variable. And we'll do the last one similarly. So time, space, and then concatenate time, the variable. Okay, so before we move on, we want to run this and make sure that it is working the way we expect it to. So here we go. We've got all 5 lines on separate lines as expected. And everything looks good. We've got spaces where they're supposed to be, dashes, all different things. So that's good. Now that we're going to move to the next section, let's talk a little bit about how we might simplify this. For one thing, we can use a single console log to take care of all 3 of these. But what's going to make this easier is if we notice that this dashed line is identical throughout this entire report, and there are 12 of them. So rather than having to keep having those over and over again, let's actually create a new variable. I'm going to say let line equals, and then I'm going to just grab that. And that way it'll be consistent every time. If I ever wanted to go back and change it, make them all, asterisks or something, I only have to do it in one place and it'll update everywhere if we're using the variable instead. So now we have a line, so we can do console log, and I can say line plus, and then, this header astronaut info, and then plus line. But you may notice that this doesn't look quite the way we expect it to. And that's because a single console log is going to print all on one line unless you do something to force line breaks. And you may remember learning in chapter 3 about the new line character. So we can, we also need a line after time before this next section. So we're going to need to put one right up front here. I'm going to say \n, and it has to be inside of a string. So I'm creating a string there and concatenating it before the line variable. And then I also need this part to be on the next line. So I'm going to put another one there. And then I'm going to put another one here inside this string so that it forces this variable here to print on the next line. So let's try that. There we go. That looks a lot better, right? But I did it in a single line with single console log instead of having to have 3 lines like this. So that's a good step in the right direction. You guys haven't learned about template literals yet, but when you do, it's going to rock your world and it will actually be even better than this. But we'll get there. That's in chapter 7. All right. So now we are going to finish this off by having an asterisk, count, colon, space, and then adding the astronaut count. And then the last one is also an asterisk with status and a space plus astronaut status. Okay. So let's just print this again, make sure that it's coming out the way we want. Yeah, and it does look exactly like the report over here. That's what we're hoping for. Okay, so now we've got a pretty good template that we can work with. Let's copy this down and then we'll just modify it as needed for the particulars of this next section, fuel data. So I need to change astronaut info to fuel data for the header. And then here, I will say fuel temp Celsius, and then use the fuel temp Celsius variable. But I need to add on that label on the end. I need to make sure that I have a space and then the letter C tacked on after the value that's in the variable, the -225. And then here, fuel level will be fuel level. And similarly, we're going to add on that percentage symbol, but we don't want a space in front. We want it to be right up against the fuel level. So we'll do it like that. So let's run this. Yeah, good. Okay, so now we're cooking with gas. We're getting along. So this is good. Let's do the next one. This is the mass data. And so we're going to have first the crew mass. And we'll get, crew mass kilograms. And then here, instead of a C, I'm just going to change that to kilograms, but still with a space between, because that's the way that it looks on the report in the instructions. And then this one will be similar. Fuel mass and fuel mass kilograms plus space kilograms. And so now I can pretty much just, reuse these for the other two, shuttle mass kilograms and total mass kilograms. Okay. There we go. Good. So we have that whole new section. Everything looks good. Yep. Okay. And we only have two more short ones here. I'm going to borrow these first 2 lines. This one should say flight plan. And this should say weather. It looks like it's a lowercase w. And this will say weather status. But we don't need any sort of label after that. So we can just remove that kilogram off the end there. And then the final report will be somewhat similar to this. So we'll copy that. And this will say overall status and clear for takeoff. And then yes, and yes is actually currently hard-coded. We might do something about that in a little bit, but for now, all we have to do is just hard code yes into that string and we're good. So let's print it. And there it is. There's the whole report all the way from top to bottom. And it does, look identical to this. And we were able to, do that in a fairly straightforward way by simplifying a few things. And so we're good. So let's move on to this bonus mission. The first one provided by Launch Code is to get user input on the number of astronauts instead of just hard coding that number 7. And, they mention here, don't forget to convert the input value from a string to a number. Now, technically, JavaScript will automatically convert it if you try to well, let me back up. So input.question is always going to return a string, but if it's something that can be converted to a number, and you try to use it to calculate, launch JavaScript will do that. And so you don't have to do it, but it's a good idea to explicitly convert it. So first, let's worry about getting the input, and then we'll do the data type conversion. All right. So if you remember, we want to make use of this readline sync library. So we need to create a variable. We're going to make it a constant that stores, has access to all the things that are in the library by requiring it like this. So input is require readline sync. And now we can use input, and we can specifically use the method question with input in order to have it go wait for the user to give a response and then return that back. And then we want to store that in a variable. So we already have the variable we want. We can just use this and just change the assignment. So the default is no longer going to be a hard-coded 7. We're going to say input.question and just use the value that comes back from the user. How many astronauts are ready to go? I'm going to put a space here, just so the prompt isn't right up against the question mark. You could also put in a new line character like this to force the prompt down to the next line. It really is up to you, but I think that'll work. So we can do that, and then that will allow us to give a different answer. So I could say, having trouble with my console here. Let me move this over. There we go. It's got this. There we go. All right. So it's asking me how many astronauts are ready to go. I'm going to say 5 instead of 7. And what should happen is you see here that in the report, it says 5. Because whatever value comes back from the user through the use of the question method on input, it assigns it as the value to, for this variable. And then down here, we're just using whatever that whatever that value is. And that's what we see in the report when it actually prints it out. So that's the great thing about variables is you can have different data, but always get a nice result with whatever the current data is by storing things in variables before you actually use them. Okay. So the other part of this was to do the data conversion. Now, right now, I'm going to temporarily do a little console log, and I'm going to say the type of astronaut count is, and then say type of astronaut count. So that you remember this type of keyword actually allows you to access, it'll say string or number or whatever. Let's run it. So I'm going to, say, I guess I need to move this back over. 3. And it says the type of astronaut count is string. So we've proven that even though I gave it something that can be converted to a number, it really does come back as a string unless you try to use it as a number. So what we're going to do, and I'm going to take this out because that was just temporary. I'm going to wrap this entire expression in the number function. I'm going to call this number function and give it that entire expression to convert to a number. So it's going to bring this back as a string, whether it's 3 or 7 or 5 or whatever, and then convert it to a number. And I guess I could have kept that type of thing to prove that it's been converted, but it's all right. It's going to work. So I can run it again. And this time it's going to say, 4. And there we have it. It's 4. And you may or may not have noticed that the crew mass has been changing every single time, and therefore the total mass, because that is based on the number of astronauts. So that value is also going to be different each time because it's being calculated here, and then that value is being used here to calculate this. Okay, Let's go on to the super bonus missions to take a look at how we might use conditionals to make a few other things in here come out, one way or another, depending on what information we're working with. Okay, the first thing is to make the astronaut status have a different value if there's actually less than 7 astronauts. We want to say 7 is the minimum that we need in order to be ready. So let's say it's not ready if it's less than 7. There's a couple different ways to approach this. There's actually several different ways to approach this. That's the thing about conditionals. You can write them a lot of different ways. We will, let's see. I'm going to add some space in here so we can work with this. So one thing you could do is you could just like not give it any value at all. You could just declare it. And then you could say, if astronaut count is less than 7, then astronaut status should be given the value not ready. Else, astronaut status should be given the value of ready. So that it has no value in this case until one of these two conditions is true. Either it's less than 7 or it's not, in which case it's either not ready or it's ready. As remember, these blocks of code inside the brackets only execute if the condition here is true. And in a case like this, where it's just a binary choice, if this one is false, it skips this part, moves on to the else, and executes this instead. So this is perfectly valid. We can test it by, saying, okay, we've got, 4 astronauts. And so now we see that this status is not ready because, it went through this logic and said, well, this one evaluated to true. So I need to run this code. And so it ran this and skipped this. But I could run it again and I could say 7. And then we would see that it's ready. So that works. But I would suggest that there is another approach. And this is pretty much the way I would do it. I would say in a situation like this, where you've got, NASA is trying to send something into space, you probably want the default value for astronaut status to be not ready until you prove that they are ready. So instead of just declaring it, I'm going to give it a default value and say it's not ready. And then I'm going to just have an if statement, but there's no reason to have an else with a default value. So in this case. So I'm just going to say if astronaut count is greater than or equal to 7, or maybe we say it needs to be exactly equal to 7. It depends on what the requirements are. Then we actually reassign the value for astronaut status to be ready. So to follow this logic, it's going to say not ready in the report unless this condition right here evaluates to true. And if it's true, then it executes the code inside here and changes the value to ready. So let's test it. How many astronauts are ready to go? We're going to say 5. And it says not ready because it skipped this code. But if we run it again, and let's say I say 7, now it says ready because this evaluated to true and it changed the value. Okay. So this is a good, basic kind of approach to starting to work with a little bit of conditional logic. Let's do one more thing here. We're going to get one more piece of user information. And this time we're going to ask the user, is the weather clear or not? And if it's clear, we're going to say that the weather status is clear. But if it's not, we'll say it's not clear. So I'm going to come to this area right down here. And I'm going to actually, before we give weather status a value, I'm going to create a new variable just to get feedback from the user and say, let weather response equals, and I'll use input again, dot question. and ask, is the weather clear for takeoff? And then Y or N. This is an old school approach, but basically says, you're giving them, telling them what you need them to provide for you. And I could write some logic that, is like, if it's no, then say not clear. If, else, or, if it's Y, say it's clear. There's different approaches. You can do this different ways. Different people think different ways. I think I'm going to use the same approach I did here, where I have a kind of safe default of not clear, that we don't actually change it to clear until we've gotten that Y. So we'll say if weather response is equal to Y, then we'll change it. Change the status to clear. Then and only then. And what this means by doing it this way is, we're not checking for N specifically. It pretty much means that anything other than a capital Y is going to prevent this from running. And you are going to learn some string methods like, 2 uppercase, 2 lowercase, and some other things about validation in the upcoming weeks, where you'll be able to actually prevent something from happening, like if they accidentally put a lowercase y in instead of a y, that it would still accept it. And it wouldn't break the program or cause it to behave in a way that you don't intend it to. Because people are people, and you have to kind of account for those kinds of things. But we're not there yet. You're at the beginning here, so that's okay. So I'm just going to be very careful while I'm testing this to always put a capital Y. And that way I will be sure that I am testing the code that I have. So let's try this out and see how it goes. So we're going to say we have 7 astronauts ready to go, but the weather is not clear. And so now we see right here that in the flight plan, the weather says not clear. And I just realized that my question here after the end, I need to have a space because it kind of put it right up against there. This is another case where, maybe I do want to have, a line break here and actually just push it down to the next line. So I could run it again, say 7. And this time, see, the prompt is now below, which is kind of cleaner. And I can say yes. And now it says, okay, I evaluated this expression. It was indeed equal to a capital Y. So I'm going to run this code and change the value to clear. And it did. Good. Okay. So now that we know, we have a way to actually check whether our astronauts are ready and to check whether the weather is good. We can also manipulate the text here so that we can say, are we actually clear for takeoff or not? So I'm going to create another variable called let clear for takeoff. And I'm going to use the negative case again and say, no, we are not cleared for takeoff until we are absolutely sure that we are ready. So let's put that in here. Instead of having that hard-coded yes, let's concatenate clear for takeoff and add that on. And so now we need to make sure that we have a case that says, what are the conditions under which we would want this to be yes instead of no. There's a couple different ways to go about this. If you're going to do it this way and have the negative case be the default, then pretty much the only way you can change it to a yes is if weather status is clear and if astronaut status is ready. So that's where those logical operators come in. We want to write a more complex condition here and say if astronaut status is equal to ready, and double ampersand is the symbol for that. And if we don't say if, but you don't type if again, but I'm just saying it. Sorry, I'm being confusing. So if both the conditions astronaut status equals ready and weather status equals clear, if both of those things are true, then execute the code that changes the value of clear for takeoff to yes. That's the only circumstances in which that'll change to yes. And we can prove it by running some tests here. So let's come in here and say, let's have less than less than 6. No, let's do the positive case because we know it's going to be no otherwise. 7 astronauts and the weather is clear, yes. Then down here you can see that yes, it is clear for takeoff. So this code did execute because both of these things were true. But if one of them is false, let's say we only have 5 astronauts ready, even if the weather is beautiful, then the astronauts are not ready, the weather is clear, but we're still not clear for takeoff because one of these 2 things evaluated as false, and they both have to be true. And then of course you can do that the opposite way. You can do it where they're both false. But I think we've kind of proven the point there. So, there's plenty of things you could practice with. I mean, you could keep going, right? You could say, well, what if the weight, the total mass kilogram is over a certain amount, or what if the fuel level is too low, or whatever. You could have all kinds of things in here that could be really fun for practice. So knock yourself out, keep adding to it if you want to. But anyway, I hope this has been helpful, giving you some practice on variables and data types and printing to the console, accepting user input and conditionals.